So what we're doing here is we have an indicial equation. The word indicial, index, it means an equation where the unknown is in the power itself, the index. So typically what you'll need to do is somehow re-express the bases so that they have the same base. That's the name of the game, because once the bases agree, we can then look at what the powers look like and solve it accordingly. So 4 to the power of x plus 1 equals 32 to the power of x minus 2. This is where that list of indices, that list of powers I showed you before comes in handy, and where if you can actually see them straight up, then it's going to make your lives a lot more easy, because you're not constantly referring to a list or trying out different numbers. So 4 and 32 can be expressed as the same base. Now I'll tell you this for nothing, 32, this number here, cannot be expressed as a power of 4. 4 squared is 16, 4 cubed is 64. So it misses it, okay? So we can't just say, well, I'll turn 32 into a power of 4. I'm just going to put my do not disturb on. Okay, so that's a no-go zone. We can't do that. But what we can do is we can look at the numbers 4 and 32 and say, is there a common base that we can express both of those numbers in? And the answer is yes, otherwise it'd be a pretty dumb thing for me to write up on the board. So 4 and 32 has a common base of 2. Thank you, Clodagh. So 4 is, oops, got to go to pen. Yeah, 2 to the 2, or 2 squared. So what I do is I replace 4 with the power, 2 squared, and have x plus 1 outside as usual. And on the other hand, I've got 32 to the power of x minus 2, and 32 is 2 to the power of... Don't Clodagh, you're on fire today. 2 to the power of 5 to the power of x minus 2. Okay? Now, remember that law that I had? I'll put it up in the corner here so that you can see it again. We're going to simply now use this law here. A to the power of m to the power of n is equal to a to the power of m times n. We're just going to use that law to expand the brackets, I guess. So on the left-hand side, we have 2 to the power, I'll just do it in one step if that's okay, 2 to the power of 2 times x, and 2 to the power of 2 times 1. So that gives us 2 to the power of 2x plus 1. And on the right-hand side, I'll do the same thing. 2 to the power of 5 times x is 2 to the power of 5x, and then 5 times negative 2 is negative 10. So I've got 2 to the power of 2x plus 1 equals 2 to the power of 5x minus 10.
Is it 2x plus 2? 2x plus 2?
Yep, thank you. How bad? Thank you. Okay, 2 to the power of 2x plus 2. So at this point here, we have bases that agree. Here, we have some numbers here, but our base is still 4, and our base is still 32. Okay, it's just that it's been rewritten as a different kind of looking number. But here, now we have the base being 2 to the power of something, and here we have 2 to the power of something. So once your bases agree, you can then set your indices equal to each other. For 2 to the power of 2x plus 2 to be equal to 2 to the power of 5x minus 10, it must follow that 2x plus 2 is equal to 5x minus 10. Okay, so that makes, therefore, probably a good idea to put that, therefore 2x plus 2 is equal to 5x minus 10. And let's see if we get a nice even. You won't always get an even, nice neat whole number out of this. Let's see if we do. But if you don't freak out. Just write it as a fraction. So I'm going to balance the equation and solve. This is basically what, a 2-step linear equation to solve, isn't it? So welcome to grade 8. Minus 2 from both sides there. That gets rid of the 2 there, leaving me with 2x is equal to 5x minus 12. And then I'm going to take 5x from both sides and leave me with negative 3x is equal to negative 12. And therefore, if I divide both sides by negative 3, I get x is equal to positive 4. Remember, a negative divided by a negative is positive. So it's right down the bottom there on your screen there, but can you see that? X is equal to 4. Okay, now if you want to, and you had a calculator handy, you could substitute it, but it's a good idea to do it. So you could go, okay, well that means that 4 is raised to the power of 4 plus 1, so it's 4 to the power of 5. Do that on your calculator. Then on the other side go, well 4 minus 2 is 2, 32 to the power of 2 is what? Do that on your calculator. If you get the same number for both of those calculations, and you know you haven't made a mistake. That's the nice thing about solving equations, is that you can always go back and check if you've got time. Don't always have time in a test. Okay, does anyone have any questions about... That's basically how you do it. I can't sit down and go through every single kind of example. The only other kind of example that's worth exploring is maybe a negative number one, and then the rest are just... I mean, you can get harder ones, but yeah, the rest are just more to do with just practicing. So if I had something like this, I'll pick a really easy one. If I had, say... Oops, go for pen. If I had 1/4 is equal to... I'm just picking powers of 2 because they're just really easy to work out, really. So 1 over 4 to the power of x, say, for example, is equal to 8 to the power of 2x. This is going to work out to be a horrible fraction because I can't be bothered working out a nice, neat answer, this one. Just making it up here. How would I deal with that one? Anyway.
You bring 4x to like numerator, so it'd be like 4 to the power negative x.
Yep, good. First step is to just make that index negative. So it's now on the same level as 8 to the power of 2x. Then what would I do? 4 is not a power of 8. 8 is not a power of 4, so we can't use that. But again, they're both powers of 2, right? So the same as before. 2 squared to the power of negative x equals 2 cubed to the power of 2x. This is going to be a horrible number. It might not even work, I don't know. I just made it up. So that's 2 times negative x is equal to 2 take away x, right? Thanks for shouting me down there to say how wrong I was there. That really disturbs me. No, 2 times negative x is negative 2x. And on the right-hand side, I have 2 to the power of 6x.
You just end up with 0.
Yeah, you will. Thanks, Anurag. So now that I have my bases agreeing, they're both powers of 2, I can now go, well, therefore, negative 2x is equal to 6x. And no matter how you slice it, we're going to get x equal to 0 as being the only way of solving that. So, for example, I can add 2x to both sides. That's okay. I mean, you can just say, therefore, x equals 0. You don't have to do this, but 8x equals 0, therefore, x equals 0. And, of course, that works. 1 over 4 to the power of 0 is 1. 8 to the power of 0 is 1. 1 equals 1. It definitely is a solution for that equation. So, a dumb example, but I was just trying to illustrate what to do with a fraction. Sorry?
So in any equation,
No, definitely not. It didn't work for the other one, did it? Yeah, so definitely not. It just happened to do it in this occasion because I didn't make it particularly complicated. Yeah. Any questions? Okay, the next kind and the last kind I'm going to have a look at before I give you some practice work is this kind of... Now, I'm just looking at this problem from the assignment that I never handed out to you, but I'm going to. So, if we have something like this, 5 to the power of 2x minus 4 times 5 to the power of x minus 5 equals 0. Okay. So, in this type of indicial equation, we are going to do a substitution. So, pay careful attention to what I do here. What I notice is that I've got a 5 to the power of x sort of hiding in here. I'll uncover it in a second. And a 5 to the power of x here. I'm also seeing a minus 5 here, but I think I'll leave that one alone because there's no index with a variable in it. So I don't want to touch that. I'll show you what I do. So what I do is I pull out that 5 to the power of x in brackets, which means it's 5 to the power of x squared, right? I'm just using that rule, a to the power of m to the power of n is equal to a to the power of mn, backwards. Minus 4 times, and I'm just going to put it in brackets so we can just sort of see that's the bit that I'm going to do a substitution, tricky substitution thing on, equals 0. Okay? Now, I'm just going to use a letter. I tend to use capital letters for this, I don't know why. Let a equal 5 to the power of x. Then what do we have? A squared minus 4a minus 5 equals 0. Now that's a trinomial, isn't it, that we can factorise and solve. A minus 5, a plus 1 is equal to 0. Is that okay? So therefore a equals 5 and negative 1. Just using the null factor law. I'm going to write that on the next screen. And of course we haven't finished yet, but I'm just saying that's where we're up to. So I'm just going to switch to the next screen now. Don't forget I'm recording this, so I will put this up as a video as well, so you can go back and, it's good because if I put it up there, you can be confused over and over again, which is handy. So therefore a equals 5 and a equals negative 1, like we saw before. But a, as you know, was 5 to the power of x, therefore 5 to the power of x equals 5. Or 5 to the power of x equals negative 1. Was it negative 1? Must have been. 5 to the power of x equals negative 1. Okay, well, let's go from here. I don't even think we need to solve this in any complicated way. Let's just do an arrow across there. If 5 to the power of x equals 5, what does x equal there? Yeah, 1, doesn't it? 5 to the power of 1 equals 5. So we've got x equal to 1. What about this one? 5 to the power of x equals negative 1. What would I have to raise x to get negative 1? Negative 5? 0? Negative 0? Let's just start off with... Not even. Let's just start off with negative numbers for a start. What do negative numbers do to... When we raise a number to a negative number, what does it do? Yeah, it just makes it a fraction, doesn't it? So if I have 5, I'm just going to pick a number like negative 2. It actually doesn't make the number negative, it just turns it into a fraction, 1 over 25. So x being negative won't give us a solution, it'll just give us a fraction which is not going to be equal to negative 1. X being positive, we can see clearly won't give us negative 1. 5 raised to the power of 0 gets us close, but no cigar there. It's positive 1. And raising 5 to the power of negative 0 doesn't do anything at all. Negative 0 is just 0. 0 is unsigned. So in other words, what am I trying to say?
It's undefined.
No, it's not under 5. Oh, undefined, sorry, yeah. I thought you said it's under 5. There we go, so we can just put no solution. I kind of like no solution better than undefined. Undefined or error kind of makes me feel like you've just used a calculator. Whereas no solution says there is no value for x such that 5 to the power of x will give me negative 1. So therefore, if I said to you, what's the solution for 5 to the power of 2x minus 4 times 5 to the power of x minus 5 equals 0, the answer is x equals 1. That is the only solution. The fact that we've got an alternative that doesn't work simply means that we discount this from our solution. Our solution being, what can x equal? X cannot equal anything off this branch, but x can equal 1 off this branch. And that's it. So basically there's two types of indicial equations I want you to get a handle on in the next 20 minutes or so. Number one is where you've simply got two numbers equaling each other and you have to change the bases. And number two, where you've got an indicial equation that can be turned into a trinomial that can be solved. And that's basically it. So these kinds of skill sets, by the way, are really important, again, when we link it back to graphing stuff, because if you can solve these kinds of problems, it means that you're able to solve graphing problems that have that kind of equation in it, which you frequently do, not always, but you frequently do in more complex exponential equations. Now, the only thing we need to do after that, and then I'll take questions, the only thing we need to do after that then is to work out, well, okay, so if I've got 5 to the power of x equaling 625 to the power of 2x plus 1, I can solve that now. But what happens if I have 5 to the power of x equaling 2 to the power of x minus 1? The bases don't agree. The bases will never agree for that. How do we go about solving that? The answer is, well, using logarithms, but we'll move on to logarithms after we've finished looking at powers. I just wanted to give you this is where we're going with it. This is the bit which we don't know yet. So I'm giving you tools, I'm giving you extra tool sets, extra tools, I guess, to work with particular types of equations, but we've still got gaps in the kinds of equations we can work with, like this one. Okay.
So if we have a question like this in a test, do we just leave it at x equals 4, or do we put, so like for the first question, do you do x equals 4, or do you like put in 4 and figure out so it's 4 to the power 5?
Assuming the question says solve for x, if it says solve for x, something like that, then writing x equals 4 is enough.
Okay.
If the question was what value, or something like that, then it should be pretty clear that it's asking you to put it back into the equation. There's only one, in the absence of other information, there's only one reason why you might put the value of x back into the equation. What would that be? Starts with ch, ends in ek. Yeah, to check to make sure you got it right. And that could be done on a scrap bit of paper, if you like. Anyway.
Is there any way to do the question you did before without using substitution, or is that like the only way you can do it?
It's the only way you can do it intelligently, I think. You could do guess and check. The only thing is, maybe if this is useful to know, is that the substitution step of saying let 5 to the power of x equal a is simply to unclutter the problem that you've just come across. So you've got 5 to the power of 2x minus 4 times 5 to the power of x minus 5 equals 0. If you've got, if you can sort of keep clear in your head that 5 to the power of x is just this thing, and say, well, therefore that's 5 to the power of x minus, what was it? Of course, 5 to the power of x minus 5, 5 to the power of x plus 1. In other words, if you don't have to let a equal 5 to the power of x, because you can sort of keep that separate in your head, there's nothing wrong with not putting a equals. But as you can see, the conceptual, is, what is this 5 to the power of x is simplified when you let it equal a, because then it becomes a simple quadratic that you've seen heaps of times. But with practice and experience, and maybe some of you are here right now, you might be able to do a straight substitution in your head kind of thing, where you've gone, well, I can see that's 5 to the power of x squared. I can see I've got a 5 to the power of x there, so therefore I can put it straight into my equation. Does that kind of answer? Yeah. I could have taken 5 as a common factor out first as well, but I don't think that would have actually simplified what I had to do next, because then I would have had 5 to the power of 2x minus 1 minus 4 times 5 to the power of x minus 1 minus 1. So I don't think that would make it easier. I think it would make it a bit harder. Good question. Any other questions before we round off this session? No? Okay. Well, hopefully that was useful for you to understand what to do next. So I'll just pause this because we don't need to have this on the video.